Hello friends, in this video we will start finite automata. Finite automata. First we will understand what do you mean by the automata. What do you mean by the automata? Automata. The term automata is taken from the Greek word automation. The term automata is taken from the Greek word automation, which means self-acting, The term automata is taken from Greek word automation, which means self-acting. Clear? This is the history behind the automata. Now, what is finite automata? What is finite automata? Finite means limited. Finite automata. Finite automata is also called finite state machine. Finite state machine. Next point. Finite automata has no temporary storage, hence it can remember finite information with the help of finite control which contain states and transitions. These two words are very important. Transitions. What is finite automata? Finite automata is also called finite state machine. Finite automata has no temporary storage. That's why it can remember finite information with the help of finite control which contains states and transitions. Clear? What is the graphical representation of this? Please listen carefully. This is our finite control. Finite control. This is input input. This is read and write head. Read head. Write head नहीं होगा इसमें, सिर्फ there is only read head. Head moves only from left to right. Head moves from left to right. Direction. It contains input symbols. This is input tape. Input tape. This contains input. Clear? This is the graphical representation of finite state machine. This is the graphical representation of finite state machine. Clear? Now, what are the types of finite automata? Types of finite automata. Basically, it divides into two categories. Finite automata divide into two categories: without output and with output. What do you mean by the without output? They does not produce any kind of output. It is also called acceptors. Acceptors. Without output. Without output. What are the types of without output? This is the broad picture for finite automata. DFA, deterministic finite automata. NFA, non-deterministic finite automata, and epsilon NFA. Epsilon NFA. The expressive power of these three are same. We can convert every DFA into NFA, NFA into DFA, and NFA to epsilon NFA. The expressive power of these three are same. Now, without output means acceptors. Acceptors. What do you mean by the acceptor? We will discuss later. Next is with output. With output. It means we will give some input to the machine and it produce some output. These are two types. First one is Moore machine, second is Millet machine. Moore machine and Millet machine. The expressive power of Moore machine and Millet machine are same. What do you mean by this expressive power? We can convert every Moore machine into a Millet machine and every Millet machine into a Moore machine. So this is the broadly classified finite automata. After that, we will discuss one by one. First, we will discuss DFA, then NFA, then epsilon NFA, then Moore machine, then Millet machine. Clear? Now, we will discuss what is acceptor. Acceptor. Suppose we have a string W over the alphabet sigma. Suppose we have a string W over the alphabet sigma. Clear? If we start scanning the string from the initial state and it reaches to the and it ends to the final state, then we can say string is accepted by the machine. Clear? If we start scanning the string W from the initial state and it ends to the any of final state. It ends to the any final state. Any final state. Then we can say string is accepted by the finite state machine, otherwise rejected. Clear? Otherwise rejected. Clear? Any doubt? No. Very good. Representation of finite automata. Next. Representation of finite automata. What are the representation of finite automata? There are two types of representation. First one is transition diagram या state diagram. State diagram. State diagram. Second is transition table. In state diagram, we have states and states represented by the circles. Clear? Every state represent by a circle. For an initial state, a circle is associated associated with an arrow. With an arrow. Next, final state represented by the double circle. Double circle. Next, next point in this, every state is connected with transitions associated with an input. This is the definition of state diagram. Now, we will discuss with the example. Listen carefully. Please listen carefully. Suppose we have a fan. Suppose we have a fan. I have fan. In fan, we don't have any regulator. We don't have any regulator. It means there are only two states of the fan. Either it is a off or it is a on. We have only two states, off and on. And on. Clear? Either off or on. Let's suppose off is the initial state. I suppose off is the initial state. Now, initial state is denoted by the arrow. And on is the final state. On is the final state. See the fan is running. See, fan is the running. This is the final state. For fan, we have two inputs. Either it is off or it is on. Either it is off or it is on. Final state we denote double circle and initial state we denote with the arrow. Clear? When we give the input to this initial state, this is the initial state, is 0. It means fan is off. If I give the input to 0, then it is always off. When we give the input in the off state is 1, then it's going to be running state. It's going to be running state. These are the transitions. These are the transitions. These are the transitions. This is the state. Now, we are in the running state or final state. Fan is going on. If we give the input continuously 1, then fan is running. If we give input 0 on this state, it goes into the off state. So this is the state diagram. This is the state diagram. This is final state. Final state. And this one is the initial state. This is the representation of finite automata with the help of state diagram. Then what is the transition table? Next representation is transition table. Transition table. How can I represent the state diagram with the help of transition table? This is the transition table where rows represents by the states. State is off and on. Off is the initial state and on is the final state. Either we represent star or circle or circle. What are the inputs? 0 and 1. When we give the input to the off state, it is always on off state. When we will give the input 1 onto the off state, it goes into the on state. When we give the input 0 onto the on state, it goes into the off state. When we will give the input is 1 onto the on state, it is going on to the off state. This is the representation of finite state machine, either by the state diagram or transition table. Is it clear? Is it clear? Now, first we start DFA. DFA. Deterministic finite automata. Deterministic finite automata. Finite automata. Deterministic finite automata. DFA. What is the definition of the DFA? Each and every state have exactly one transition on every input symbol. Listen carefully. I repeat. Each and every state have exactly one transition on every input symbol. Clear? Each and every state have exactly one transition on every input symbol. This is the definition of the deterministic finite automata. What is the formal definition of this? A mathematical definition for the DFA. Formal definition. Formal definition. A DFA can be represented by a DFA can be represented by 5 tuples. क्या क्या है 5 tuples? What are the 5 tuples? capital Q, sigma, delta, Q naught and F. Where capital Q is a set of finite states. It includes final or non-final states. Sigma is a input symbol. Q naught is a initial state. F set of final state. F is a subset of Q. What do you mean by this? One transition diagram have more than one final state. Suppose we have a regulator in an example, then if we can consider as a 1, 2, 3, 4 are the final states, then transition diagram contains more than one final states. Transition diagram have more than one final state. Next is delta. This is a transition function. What do you mean by the transition function? What is the definition of the DFA? Each and every state have exactly one transition on every input symbol. This is the transition function for DFA. Each and every state have exactly one transition on every input symbol. Clear? Now check with the example. We consider a fan example. Input symbol is 0 and 1. Q off and on. We have two states. Q naught is equal to off. Final means on. And now we check what are the transition function. This is the diagram of on. When we will give input 0, then it is on off state. When we will give input 1, it goes into the on state. And this is this. Now check. Is it DFA or not? We have only two input symbol. On the state off, we have two transitions for 1 and for 0. On state, we have only two transitions for 1 and for 0. It means, what is the definition of DFA? Each and every state have exactly one transition on every input symbol. What do you mean by the transition function? Off and on. We have only two states. Cross. Number of input symbols 0 and 1. So what are the transitions? Off, comma 0, off, comma 1, on, comma 0, on, comma 1. These are the four transitions. We have only four transitions. Check. This is the first, second, third, fourth. Clear? So what is the definition of the DFA? Each and every state have exactly one transition on every input symbol. each and every state have exactly one transition on every input symbol. Now, next video we will discuss lot of examples for regarding the DFA.